So looking at page 215 in your text and starting with the exercises 4-3 here, this is that introduction to percent. And the first thing that they're looking at here in section A of this section is to convert the values that we see for the different numbers here to percentages, okay? Now, the easy way that they showed in the Math was really to just move. When we want to change something, whether it's a number or a decimal, to a percentage, we move that decimal place 2 places to the right, correct? So it's real easy to do for these. We can go 1, 2 places. The decimal place is going to be there. And then we add the percent sign, right? Piece of cake. So everybody feel comfortable with moving that decimal place. I don't expect you, for problems like this, to write out the divide by 100 and then equal to. Simply write 0.32 as 32%. Done deal, okay? So there's no work involved in those types of problems. Everybody feel comfortable with that? Okay, so any questions on the ones I have highlighted here as we look? So for number 10 here, we have 0.075. We would move 1, 2 places to the right. It would be 7.5 and then add the percent. Okay? All right. I'm going to move on if there's no questions. So on the next page, you'll notice that at the top, this is where they take those fractions and they want us to convert them to percentages. So here we're not in that decimal form yet. So we first have to go to decimal form and then convert to percentages. So whenever we see fractions, we know we're going to divide the top by the bottom. So this would be 5 divided by 4, and it's going to be 1.25. So even though there's a whole number here, or a 1 in front, we're still going to move to the right 2 places to get our percent. So do you see how this would be? I'm going to write it up here. 125%, right? 2 places to the right still. If we look at 3 7/10, now this one I can kind of do in my head. Whenever I divide by 10, that's just 1 decimal place, right? So this 3 7/10 would be 3.7 as its decimal equivalent, and then we would convert it to its percentage, which would be 2 places to the right, so 370%, right? Any questions there? All right. Everybody feel comfortable with converting even fractions into decimals, then to the percents? Okay. Going the opposite way, when we start with a percent and going to the decimal number, we move our arrow or our places to the other side. So we're going to move the decimal 2 places to the left, right? That's like dividing by 100. So here, if we have 6%, we can say this is going to be equal to 6, right? Without the percentage. The decimal is imaginarily, if you would, on the right-hand side here of the 6. So to move it 2 places to the left, 1, 2, my decimal would be here, and I'd have to fill in a 0. So here the decimal equivalent of 6% is 0.06. Okay? For 456, decimal is going to be here at the end right now, and I move it 2 places to the left, so it would be 4.56 decimal equivalent. Everybody feel comfortable with that, going in the opposite direction? Any questions there? Okay. All right. I'm really not going to focus on rewriting percentages as fractions. I think I don't know. I don't see practical applications of that, but just know that if you do have it, it's really over 100, and then you put it in its lowest terms, right? It's really that simple. So I'm not going to worry about that stuff. So if we go to page 228, so we're going to kind of skip over a couple sections here. If there's something that you do indeed want to review, go back. This book does a nice job of laying things out step by step. I really like it. I think it's a great resource. Pricey, but it's a good resource. It's worth it. The next section here is looking at special applications of percent calculations. And really, it's like taking these percentages and using them in common ways in our everyday life, okay? So the first one here is figuring out a discount. I always like, I don't know, some of you maybe more than others, when you go to the store, it's always nice when things are on sale, right? And they usually will say 25% off. Well, they'll give you the price on the tag, but it doesn't tell you what that final price is. So we want to usually figure out, okay, what is this actually going to cost me when I take it up to the register? So net price is going to be the price that you pay in the end, and it's going to be equal to your list price minus your discount. Most often, your discount is given to you as a percentage, right? Okay, we see it a lot that way. So you can also set it up as a proportion, and I'm going to have to kind of push this up a little bit. You can say that our part, which is going to be the percentage, the discount of the part, over the base, which is the list price, is equal to the rate, the discount rate, over the 100%. That's another way to look at it. Or, using variable form, we can say it's D for the discount over the list price is equal to the discount rate over 100. Okay? So most often what we're interested in is this guy right here. What is that price I'm going to pay at a discounted the discounted price based on the discount rate over here? Okay? So, an example, number one, it says we have the list price of a tool is $18.50. All right? It's on a special sale, and it's offered at 20% off. Okay? So, what is the net price? Okay, I'm going to tell you two ways to look at this. All right? I can either do it in one step, or I can do it in a couple, like they see here. Let's see the couple steps first. So, the first thing we would do is we would say, okay, I want to figure out what my actual discount is. Now, they show it as a proportion. I wouldn't do it as a proportion. How would you guys do it to figure out the discount? So if I'm getting a 20% discount off of $18.50, how would you directly figure out how much money am I getting off? What is my discount? Yes. Let's not set up these proportions. Do you like that? I think it's more confusing, actually. So here, if my list price is $18.50, right? I'm just going to simply multiply that by 20%. But I can't do it times 20. I have to do it by the decimal equivalent of 20%, which is 0.2, right? So 0.2. So that means I'm going to get $3.70 off. Everybody see that? Okay. That's what they got right here through that proportion business.
I'm not going to go to a store and try out proportion to figure it out.
Exactly. I'm not going to go to a store and do a proportion. I'm going to get out my phone and I'm going to say $18.50 times 0.2. Oh, I'm going to save $3.70, right? Okay. So that's how. So you don't have to do the proportion to get there. Just multiplying it by the decimal equivalent of the 20% here, a 0.2 gets you the $3.70. But we're not done. We want to know what our final price is, right? What am I actually going to pay? So I need to take $18.50 minus 3.7, and my final price is going to be $14.80. Now, I go to the store and I want to do it a little quicker than that. All right, I want to do it in one step as opposed to two steps. Can you think of a way that I can do that in one step to get my discounted price? How could I do that? Go ahead. A 1 in front of which one? In front of the percentage. You can do that. I'm going to give you one more way to do it. If I know that, and I like this little pie graph down here. If I know that my whole price is 100%, right? The full graph. And I'm going to get a discount of 20%. I'm going to multiply by 0.2 to get that discount, right? To know what that value of the discount is. But let's say I just want to know what I want to pay in the end. How much of it am I actually going to pay in the end? 80%, right? So how about if I do this? Instead of saying $18.50 times 20 and then subtracting, if I go 18.5 times the leftover amount, 0.8 directly, oh, I get my $14.80 right away. So when I'm in a store and I'm looking at I usually go to the clearance rack section. If I go to the clearance rack and they're saying I get 30% off, okay? Let's say it's $18.50 is the list price of what I'm doing. Okay, I want to go directly. So I know I'm going to get 30 off, so I'm going to pay 70%. So I'm going to then say times 0.7, and I'm only going to pay $12.95 for that item then. So you see how you can get there directly by using the leftover part of the whole. Does that make sense to everybody? So either way, I am completely fine with you working. So if you wanted to figure out the discount and then have that number and subtract it, fine. Or if you wanted to go directly and say, I'm going to take that original list price and multiply it by what the leftover that I'm going to actually pay. So in this case, 0.8 as opposed to the 0.2. Has everybody ever done that second way before? No. And it's just another way to think of it, right? Do you agree? Okay. All right. So that's doing a net price based on a discount that you get. Okay, so subtracting that off. We're going to peek ahead a little bit. Sometimes we want to know what a percentage is of a number. So we're going to see problems where we say, okay, find 20% of, in this case, $620 or $640. Okay. In some cases, let's say, I think of when I was out in industry and we would design machines. If we would have this, this big number, let's say to design this machine, build it, and get it into your facility, it's going to cost $600,000. Okay, and then what happens is you commit to a day that you're going to deliver. Okay, now let's say we don't make the delivery date. Typically in the contract, you say, okay, for every day that we're late, you're going to get X amount of percent off of the price. So maybe 5% off per day. So I got to know, well, what does 5% mean to me when I made a purchase of $600, if I'm going to get $600,000? How important is that? So in that example, per day, when I take 600, 1, 2, 3, times 5% is 0.05, ooh, that's going to cost me $30,000 a day. Now that's maybe not practical, of the amount. So 5% of 600,000 is 30,000. Is that right? That seems big, doesn't it? 600, 1, 2, 3, times 0.05. No, $30,000. Probably isn't going to be the terms I agree to per day. Maybe it's going to be 0.5% instead. But notice how it ties an actual value to that. So I want to know, as a percentage of, how much is that going to cost me per day, basically. So it becomes really important in this case to make the date, right? Make that due date. Because customers don't want to be waiting months out and think that you're sitting on it. So figuring out a percentage of an actual value is how we would see this here. So to figure out, let's say 20% of 640, we would say, we would convert the percentage first to its decimal equivalent, so to 0.2. So 0.2 times 640. So $128 in this case would be 20% of 640. Okay. They're showing a second option here to maybe check your work for the proportion. All right. So any questions on finding a percentage of a number, switching it to its decimal equivalent and then multiplying that decimal equivalent times the number. Okay. Tax, go ahead.
On the homework, you want us to show like what we got for the decimal equivalent times what we got, or just?
You can go directly. I'm fine with the answer in that case, yeah. Okay. Yeah, because these are really short and to the point. All right. When we did the proportions and the ratios, I do want you to write those out because in those it's all about setup. Okay. And if I can see that you line things up across those couple of lines, I do want you to write out. Yes.
I just want to look. So if you just want the ratio, can you give you like the size of the pulleys?
Right. Well, you know what? Before I let you loose on the homework, I'm going to go through each section and let you know exactly what I want. Okay. So. All right, so we're going to go to the next section here on the bottom of page 233. They talk about sales tax, okay? We experience sales tax on a daily basis, right? So are we all comfortable with sales tax and figuring that out? So ours is what, 5%, right? So we multiply by 0.05 to get what that value is. Okay.